Determining the maximum number of 350 kcmil conductors permitted in a 2.5-inch conduit involves understanding conduit fill requirements as specified by the National Electrical Code, or NEC. Conduit fill refers to the percentage of the conduit's cross-sectional area that can be occupied by conductors. The NEC specifies these fill limits to ensure adequate space for heat dissipation and to prevent damage to the conductors during installation. Firstly, consult the relevant tables in the NEC, specifically Chapter 9, Table 4 and Table 5. Table 4 provides the dimensions and cross-sectional area for different types of conduits, while Table 5 lists the dimensions and cross-sectional area for various conductor sizes and types. These tables are essential for calculating conduit fill accurately. Secondly, identify the type of conduit being used. Common types include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or INT, and electrical non-metallic tubing, or ENT. Each conduit type has a different inner diameter and cross-sectional area, which affects the allowable conductor fill. For a 2.5-inch conduit, the internal area varies depending on the material. For example, a 2.5-inch RMC conduit has a different internal area than a 2.5-inch EMT conduit. You need to know which conduit type you are dealing with, so you need to identify which conduit type to look at in their respective NEC tables. Thirdly, determine the conductor type and size. In this case, the conductor size is 350 kcmil. The NEC specifies different conductor types such as THHN, THHW, and XHHW, each with different insulation properties and overall diameters. The insulation type affects the overall diameter of the conductor, which is crucial for calculating conduit fill. Again, you will need to know this piece of information, as you should verify what type of wire it is in the respective NEC tables. Fourthly, calculate the cross-sectional area of the conductors. Using NEC Chapter 9, Table 5, find the cross-sectional area of a single 350 kcmil conductor of the specified type, such as THHN. Multiply this area by the number of conductors to determine the total cross-sectional area occupied by the conductors. This is crucial for determining if the conductors are following the fill limits of the conduit, and one of the most important pieces of information. Fifthly, determine the allowable fill percentage. The NEC specifies different fill percentages based on the number of conductors in the conduit. For example, for 3 or more conductors, the allowable fill percentage is typically 40%. This percentage is based on the NEC and should be followed. Sixthly, calculate the allowable fill area. Multiply the internal cross-sectional area of the 2.5-inch conduit by the allowable fill percentage to determine the maximum area that the conductors can occupy. This value is compared with the calculation done in the fourth step. Seventhly, compare the total conductor area to the allowable fill area. Ensure that the total cross-sectional area of the conductors does not exceed the allowable fill area of the conduit. If the total conductor area exceeds the allowable fill area, you must either reduce the number of conductors or increase the conduit size. Eighthly, consider directing factors. The NEC requires ampacity directing of conductors and conduits when there are more than 3 current carrying conductors. This is because the heat generated by the conductors can raise the temperature inside the conduit, reducing the ampacity of the conductors. Refer to NEC Table 310.15. B3. To determine the appropriate directing factors based on the number of current carrying conductors. Ninthly, apply the directing factors. Multiply the ampacity of the 350 kcmil conductor by the directing factor to determine the adjusted ampacity. Ensure that the adjusted ampacity is sufficient for the intended load. If the adjusted ampacity is insufficient, you must either reduce the load, increase the conductor size, or reduce the number of conductors in the conduit. Tenthly, account for grounding conductors. Grounding conductors also must be included when calculating conduit fill, although they typically do not contribute significantly to the total fill area. The size and number of grounding conductors must comply with NEC requirements. 11thly, review NEC Chapter 9, Table 1 for conduit fill requirements based on the number of conductors. This table specifies the maximum percentage of conduit area that can be occupied by conductors. Make sure that your design is within the allowable limits. The answer to the question is 11.